Hi everyone, Aaron from ENKI. Today we are going to turn a ThermoEngine application into a more standalone app. So VapoRock is an application that I have created that couples together the MELTS model with a whole bunch of vapor species thermodynamics from JANAF tables so that it can tell you what happens, what is outgassing out of a liquid. This is really cool for modeling extrasolar planets, for modeling volcanic outgassing on Earth, all sorts of things. But the problem is that it depends on ThermoEngine, and ThermoEngine is a little hard to install on many machines. So we're going to figure out how to create a standalone app for VapoRock using Docker. Any machine that has Docker installed on it, we should be able to run and develop for VapoRock. So I can try a make dev install and see what happens. So this is how you actually install VapoRock, is with make developer install. I want developer install because that makes it editable. So if you change the code at all, it'll automatically update the installed version. And it says, could not find a version that satisfies the requirement ThermoEngine from VapoRock. No matching distribution found for ThermoEngine. ThermoEngine doesn't exist here, so you can't install VapoRock. That is the core of the issue, the nut of the issue right here. So what do we need to do? We need to have Docker come to the rescue. So let's do ENKI portal GitLab. We'll go to GitLab's ENKI portal, and there are many different options here, but one of them is the iron titanium oxide geothermometer app. So let's start there. In here, in the main page here is a Docker file. And that Docker file, basically the idea behind Docker is it's not really a virtual machine. It's more than a virtual machine. It creates a little container that runs a tiny, clean version of Linux and just the bits and pieces that are necessary to run your app, your application. And the key line here is the first one. It says, create a container from GitLab.com ENKI portal ThermoEngine master. So it says there is an image of what my container should look like up at GitLab at ThermoEngine, and inside that container is a working version of ThermoEngine. So we now have a Docker file and a Docker run script that allows us to develop locally inside of a container. So I think this is super, super exciting. So the Docker file is actually quite simple, and I've added comments. So first we pull the container from the Docker repository at ThermoEngine on GitLab. Then, and this is very important, you have to copy everything in the local folder, which is the VapoRock folder, into a specific location in the container first. So you copy it to the home folder, and we've defined, to be totally general, so this could be reusable for other projects, defined an app folder. So whatever your application is, whatever your package is, that stuff is going to get copied to the app folder. Then there's this very important resetting of permissions. There is some fixing of the permissions that needs to be done in order for the container to work properly. Then there's some stuff that we don't need that has to do with cloud apps, but this is not a cloud app right now. It's just local development. And then the last piece is switching into the app folder inside of a Docker file that's using the workdir command rather than change directory, and running a make install. It has to do with a make dev install. In this case, it's make developer install, so that you can actively develop and all of the changes will be automatically recognized, but it's basically just installing it in your local Python. And then you switch back out to the home directory. That's all that's in the Docker file. Then, and there is another key point in here, we have a nice script. This is based on the original run Docker locally shell script in ThermoEngine. It's been generalized and cleaned up a bit for general usage. So we want to know what is the name of the image, that the Docker image that's going to be created when you build this this container. Well, you build the image and then create a container from it. So I'm calling it VapoRock image, and the base directory, and this is basically true of everything that's built on top of ThermoEngine for now. The base directory is something we don't control. It's inherited from the ThermoEngine image. It's called home/Jovian. So then if you just call this script at the command line, it'll build from the Docker file your app image, and then it will run it, and it will run it using Jupyter enabled. So it will do port forwarding as it should to make it accessible from a browser window. It will enable JupyterLab. This user root enabled, I'm not sure that's actually required anymore. We might be able to get rid of that. But the key point here, this is the absolute most keyest point, is that the volume is, we define a volume which is the working directory, VapoRock directory, and the app directory inside of base dir. What that volume does, without this, the whole thing falls on its face. Without that, any changes that you make inside the container when you're developing either at the command line or in a Jupyter notebook, in JupyterLab, or inside of VScode, it doesn't matter. Any changes you make will not persist. As soon as you close the container, they're gone. Poof, gone forever. So what this does is it says, nah, everything that's in the current working directory, the VapoRock directory, or whatever your project is, will be copied and mirrored inside the app directory. And so that means that you can go into the container, work inside the app directory, make any changes you want, close down the container, destroy the container, and destroy the image, and all the changes were saved on your local computer inside that working directory that you were in, which is totally awesome. And then we start the notebook. So that's for JupyterLab, and essentially the same thing. If you want to run at a terminal, it builds it, then it runs it with the same volume definition. Without that, the whole thing doesn't work. And it starts up bash so that you have a terminal command line script. So I'm going to show you what this works, how this works, what it looks like now. So we're going to open up our terminal. We're inside VapoRock here. We are going to, there's no Docker images available right now. And so we're just going to run Docker locally. And first we're going to do it just without any extra arguments. That will start up JupyterLab. So I can show you, for those of you who prefer to work in JupyterLab, which is really nice for developing little notebooks and playing around and things. Now, there is an error here, directory not found. There's something that's not quite configured correctly in here. So if you just dismiss that, that error doesn't actually cause any problems for the usage. Something that I will figure out down the road. So now we can see we have an app directory, and inside that app directory is our whole VapoRock directory. We have all the files that were available. We can, for instance, go into notebooks, open up the basic demo, and we should be able to run this. I actually haven't tested this in this framework, so we're going to find out. It looks like it's running. I think it's running. Haha, it's working. Good. So here I will show you this one. What is this? This is a plot of, as a function of temperature, the density in the atmosphere of all these different vapor species in equilibrium with a with a bulk silicate earth composition. So this is like vaporizing the mantle of a planet. What is the atmosphere going to be over that vaporized mantle after it's degassed fully? So there's no water or CO2. So that's super cool. So that totally works. And the other thing we will show, if we go back into app, we can create a file. We will rename that file test.tech. So now there's just a file called test.tech. We're not going to do anything with it. And we're going to discard this. And we're going to close down. Everything worked. Now keep in mind, ThermoEngine does not normally work on this computer. So it was able to run VapoRock, which requires ThermoEngine to function. So it was running ThermoEngine, calculating chemical potentials, all that stuff. And now we're going to close down the container, Docker PS. The container's gone. And yet, there is test.tech. So changes that were made inside the container were saved locally. No problem. And if we were to say git status, we would see, oh, there's this new file, test.tech. So that means that you can develop locally inside JupyterLab. Now let's try the other way. I'm going to remove test.tech to clean things up. And we can also run Docker locally and give it the term argument. And it'll start up in all the same way, but it will dump you into a terminal. So you could work just locally right here, go into app. Look, here's everything. Let's say I want to run all the tests. I can go PyTest, and it will discover the tests. And bang, it will run the tests. And there are 6 tests for VapoRock. There's sort of fairly minimal automated testing, but it makes sure that everything is working. And 8 tests for VapoRock. And that all works, and we can also create a new file, test.txt. And if we now exit and run Docker PS, it will show you, yep, there is no container that's running right now. And yet, there is test.txt. So it saved those changes, no problem. So that's great. And then there's a third way that we can run this. So now we're going to actually do the same thing. We could do this with the terminal or without, whatever you like. I think it's, if you're going to do it this third way using VScode, I think it's nicer to use the terminal version because you have a terminal here where you can run PyTest or check things. It's more useful and more general than having a Jupyter notebook open. But either one would work. And then, now that we have that, we can open up VScode. And we can click on this lower left thing, open a remote window. And it allows us to attach to a running container. And it will list all the running containers. And notice it says VapoRock image and then a hex. A hash, like a hex name, unique ID for it. It also, for whatever reason, comes up with a random 2-word name that's always funny, like Focused Hellman or like Explosive Feynman, I think was one that I got recently. So it comes up with a weird name, but you can see it says VapoRock image. So if we click on that, it will open up an entirely new window and it will load it. And here we are. Here's the app directory. And here it is. So here we can make any changes that we want here. So like, for instance, I could create a test VScode.txt. There's now a new file, test VScode.txt. We can also run one of the Jupyter notebooks directly in VScode. This is actually how I prefer to run Jupyter notebooks. They're like nicely, so this is the same notebook we saw before. And if we go to the end, look, here it is. And everything is plotted. The same plot of density versus temperature for all those vapor species. So everything works just fine. We also, this is super cool that this works. If you click on testing, it will automatically find all the tests Here they are, and you can run all the tests. Now they're going to be a little deeply nested. Probably I could do better with defining where they are. But here are all the tests. It's me, so they are nicely and neurotically named. So testing VapoRock speciation, the densities, the data that you can get distinct answers for different databases. You can use different ways of doing the calculation, different approximations, and that you can make sure that the activity method and the chemical potential method for calculating species abundances agree with each other. So this is great. Everything works. So now let's, and any changes that we were to induce, why don't we do that? Because we didn't actually show that part. Let's say we go into VapoRock, into the actual package itself, and we do a quil.py, and I'm just going to add a little test var equals hello, and we'll save that. Okay, so now I've edited the actual script itself. Keep in mind that this is installed using the developer approach. So actually, I can rerun the tests now and verify that the tests still all pass. So because this doesn't actually affect anything, all the tests should still pass. Hopefully, that's true. Should be true. Yes. And if I were to introduce a problem like define new func, and I just leave it like that, that's a problem. Like that is not allowed, right? In Python, I would have to put like a pass here or something. And now all the tests, there's a discovery error. It immediately lets me know that this is not correct. And if I delete that, it should show that discovery error, I think, may go away on its own. Yep, and the discovery error goes away on its own. The other thing that we can do that's super cool is if we open up the test directory and I change one of these tests, I'm going to manually make one of the tests fail. Assert false. And now I'm going to rerun the tests. That alone should make the tests, one of the tests fail, that first test. Because all of these changes are automatic. Which is perfect for development. There's got to be a way to open those all up automatically. So I think it's this test VapoRock speciation. That one should fail. Yep. Excellent. And if we get rid of that, and rerun that one test should now pass. There is one other thing we could do that would be nice. How about let's do something really silly. Let's comment this out. Okay? Now there's no way this model can work anymore. So we're going to save that change. And if we rerun, all the tests now should fail. Well, almost all the tests. It's possible there might be one test that, yeah, okay, there are a couple tests that somehow managed to pass. But all those tests, so I changed the code inside the container, and it automatically detected that change, reinstalled the new version of the code, and the tests respond immediately. So this is like perfect for development. And if I save it back the way it was and rerun the tests, all should be good again. Yep, all is good. So now what we're going to do is we're purposefully going to leave this change right here. And we will close this out. Notice here, This is still inside the terminal, and that test VScode.txt is still inside the container. I'm now going to exit the container, which will tear it down and delete the container, and yet test VScode is still there. And if we do a git status, we see changes in the notebook because it auto saves some of those changes. A change in equil.py, that should be that variable that we defined. What's different? Oh, interesting. It did an automatic reordering of the imports because I have some features in VS Code on now. But the main difference here is that this hello is there. So that persisted outside the container. So we're actually going to just get rid of all of these. And then before we do that, what's the difference in the test? I'm guessing that's order of imports. Yeah, because of the features that I have set there. Oh, and also a new line, the lack of new lines. So there's small changes that have to do with formatting. So we're actually going to get rid of all those changes. Restore here. I think we can do that. Yep. And now it just says, oh, there's this new file. So we're just going to remove the new file. So this is a perfect setup for developing locally inside a Docker container, regardless of your system. This will work on Linux machines, like the one I'm doing it on, Mac machines, and it should work on new Windows machines that are running the newest operating system. Old Windows machines, there is a workaround, and maybe I will add a link to that. There is a workaround that exists for it, but it has to do with the ability to run essentially a Dockerized version of Linux on the old Windows machines. That doesn't work very well. But this works on Linux and Mac out of the box and should work on new Windows machines. So this is perfect. We're going to immediately start using this in a new project, which I am very excited to start working on, having to do with magmatic evolution. So yay for science. Otherwise, thank you everyone, and bye for now. Bye-bye.